Hi everyone. I'd like to introduce today Ella Clark from Aecom. Who would know ventilation would be such a hot topic? In the last 12 months, 18 months, it's become even more important. And let's think about that combined with COVID issues, with climate change, all the rest of it. And Ella, over to you. You're going to talk to us all about ventilation and health and sustainability. Thank you.
Yes, hi. Hi, everyone. My name is Ella Clark, and I'm a mechanical engineer in Aecom. I am going to talk today about the role of ventilation for health and well-being, and then its balance with energy efficiency. I work in the commercial fit-out team here at Aecom, so this presentation has quite a lot of focus on the office sector, but obviously it's all relevant to building services. As you may know, we spend on average 90% of our time inside. And so it's reasonable for us to expect a certain level of quality and safety from these spaces. Ventilation plays a central role in ensuring that the air that we breathe is clean and safe. And so as a building service engineer, it's my job and our job to ensure that the ventilation systems are designed to provide that. So the importance of good ventilation in buildings, in particular in office buildings, has been understood for quite some time. So the term sick building syndrome came about in the late 70s as people began to suffer with symptoms such as eye irritation, lethargy, and a stuffy nose at work. And people came to realize that this was because an increase in buildings being designed to be airtight and energy efficient, and these required mechanical ventilation. And so this, along with a rise in the use of synthetic building materials and the open plan style offices, meant that there was a drop in indoor air quality. So since then, many studies have been carried out, and much more is understood about the importance of ventilation systems inhibiting the circulation of harmful pollutants. And reports of sick building syndromes are far less common than they were before the millennium. So more recently, ventilation has come under scrutiny as a key transmission route of COVID-19. And on the back of that, it's also been found to be one of the best ways to mitigate and manage the spread of it. So studies have shown that actually doubling the rate of ventilation into a space reduces the potential exposure to the virus by half. And the World Health Organization has recommended that ventilation is the first mitigating strategy when trying to get people back into the office. So in 2021, with the UN Secretary General calling the IPCC's most recent report on climate change a code red for humanity, and with building operations accounting for 23% of the UK's total greenhouse gas emissions, ensuring the freshest and also safest air inside of our buildings isn't always that simple. So today I'm going to look at how strategies to ensure health and well-being through ventilation can possibly impact a building's sustainability, and look at a couple of solutions as well. So the fundamentals of ventilation. So ventilation is generally defined as the movement and distribution of air within a space. And it has three fundamental purposes. So temperature control, the reduction of moisture in gases and odours, and ultimately occupant comfort. So temperature control is typically the main consideration when designing an office space or any space, as it has a very big influence on occupant comfort. Being too hot or too cold is very easy to notice, and I'm sure it's a very popular complaint and made in offices all around the world. So the British Council for Offices recommends that design temperatures in air-conditioned spaces should be between 20 and 24 degrees centigrade, depending on the time of year, with the legal minimum requirement in an office environment being 16 degrees. So it's also widely acknowledged that temperature plays a big influence on occupant productivity. I'm sure we've all felt more tired when it's hot around us, it's harder to focus. And a study by NASA actually showed that for every 1 degree of temperature increase above 22 degrees centigrade, human productivity falls by 3.6%. So there isn't as much research to suggest that change in temperature affects our physical health, quite like it does our mental health almost. But maybe just a couple like muscle stiffness, that kind of thing when you're sitting somewhere cold for too long. Now, with heat recovery and air handling units capable of achieving efficiencies of around 90%, changing the temperature of the fresh air circulated is not always, or not necessarily, the main issue in building efficiency. but an issue arises when the amount of fresh air circulated is increased. According to WHO, whilst the pandemic is ongoing, the percentage of outdoor air circulated should be as high as the system is capable of. Now, BCO recommends that fresh air rate should be at 12 litres a second per person, and with an extra 10% for high density spaces. And CIBSE recommend a minimum of 10 litres a second. But studies have shown in hospitals that even using 120 litres per second per person in a top-down mixing ventilation system is unable to remove a virus from a ward. So this suggests that to effectively impact viruses in a space, the amount of fresh air introduced when using top-down mixing is going to have to be a lot higher than the BCO recommended 12 litres a second. And so such increase, or any increase really, in the fresh air rate is going to impact the energy demand on a building's HVAC system. So according to a 2012 study across 3 European locations, it was found that increasing the fresh air rate by as little as 0.28 litres per second per person could result in a total HVAC-related energy demand increase of between 0.1 and 0.6 kilowatt hours per metre squared per year. So for the office, Aecom's office in London, which I'm in at the moment, enough space for about 12,000 people, not 12,000, 120, 12,000 people. This could mean an increase of up to 5,000 kilowatt hours per year, which is obviously quite a lot just for that 0.28 litres a second increase. Now, how do we potentially tackle this? So one strategy is displacement ventilation. And displacement ventilation used to be quite a popular ventilation strategy in buildings, but has fallen out of favour in recent years. Potentially, people have found that apparently putting the services in the ceiling void allows you to make a 2% cost on the building spend. And also maybe because of the trend of services in offices maybe as well. But according to multiple studies, displacement ventilation, when compared to top-down mixing, can reduce the energy demand for cooling and space heating by over 20%, due to the low velocity at which the air is supplied, and also the fact that the air is supplied at a higher temperature. So in the summer, the cooling requirement is lower. So with displacement ventilation, air is supplied at low level in the space. It gets warmer. It's drawn to the heat sources of the occupants and the equipment in the room, and it gets warmer and it becomes more buoyant, so the air rises. And this effect allows the air to draw the stale air in and any potential pathogens away from occupants to be extracted at high level. Research again on hospital wards has confirmed that displacement ventilation is far more effective at removing polluted air than traditional top-down mixing, with 4 air changes an hour in a displacement setup being far more superior to even just 6 air changes an hour in a mixing setup. So with smaller energy demands and better air, displacement ventilation seems like a win-win. But as I mentioned, we have already seen a shift away from this technology, and one would think that this was because of a fairly good reason. I know that displacement ventilation does take a lot more coordination between designers and consultants, and it's definitely not viable for all spaces, but potentially this is something we should be looking at going back to in the future. So another fundamental of ventilation I mentioned really is the levels of humidity in a space. So humidity, unlike temperature, has a much more profound impact on our physical health. So relative humidity is recommended to be between 40 and 60%. However, research in the UK 2017 found that the average reported humidity levels were just 38%. Now, long-term exposure to levels of 35%, so just 3% lower than this average level, can quickly cause problems such as irritation and throat and nose dryness. Low levels of humidity have also been shown to prolong the longevity of viruses. So a study by the US government showed that at 23% relative humidity, 70 to 77% of flu virus particles were still able to cause an infection an hour after becoming airborne. And when the humidity rate was raised to just 43%, only 14% of flu viruses could still cause an infection. At the other end of the scale, though, too much humidity can allow bacteria and viruses to thrive, causing other illnesses and resulting in mold growth as well. But I think with research suggesting that offices are often below even the lowest recommended level, I think we can safely say that maybe humidity levels in UK offices are often disregarded. So in hot and humid states in the US, it's estimated that dehumidifiers account for 40% of their total HVAC energy use. So if we were to start putting humidifiers into our HVAC systems as well, would we be hugely increasing the energy demand of our system, which already accounts for 40% of our total building energy use. So it mainly depends on what type of humidifier you use. So traditionally, electrode boilers have been used as humidifiers, but these have very high maintenance cost, and they're also very energy intensive, and they're also expensive to retrofit. In-room systems like resistive humidifiers are cheaper and simpler to install and retrofit, but they do also have a very high energy consumption. Alternatively, gas-fired boilers are more energy efficient, but I feel like with the gas boiler ban coming into effect in homes in just 3 years' time, I feel like the use of gas-fired equipment probably is going to become an increasingly unpopular option. Now we've got cold water humidifiers, which are a kind of maybe up-and-coming technology in the UK, and they require a lot less maintenance and a lot less energy to run. They work on the principle of evaporative cooling, which has been utilised as far back as ancient Egypt. Now, direct evaporative cooling is the process of adding water directly to a fresh air stream to raise its humidity levels and lower its temperature. If you remember in the summer during the heat wave, there were recommendations that if your apartment was too hot or whatever, you get a fan and you put it in front of a big bowl of cold water. Now, that's exactly the same process. It is a very efficient cooling method. So it can increase efficiency of up to 28%, according to a study in London. However, it does really limit your control over the humidity levels. So alternatively, you can use indirect evaporative cooling, where the process, the humidity levels aren't changed as much, and as the supply air for the space and the water aren't actually mixed. So what happens is the extract air from the space is passed over water and cools it. And then this is passed over a heat exchanger with the supply air to transfer the heat. And so obviously this method doesn't achieve such large energy savings, but it does have the benefit of in the winter when we're heating rather than cooling, the heat exchanger can still operate just without the use of the humidifier. Now, the use of evaporative cooling in the UK is sometimes met with surprise, as we typically have quite high levels of humidity. However, when we do have warmer weather, our relative humidity is quite low. And so evaporative cooling can be effective in the UK. And the psychometric chart on the screen here shows the London weather data for a year and what type of cooling or heating method could be utilised. So it demonstrates that although most of the year is spent in heating mode, which is the red section, when cooling is required, 70% of the time the weather conditions would be appropriate for the use of evaporative cooling, which is shown in the green section. And only 11% of the time, which is yellow, would the system be required to use solely mechanical cooling. So although a larger fan power is required for evaporative cooling, which is obviously an increase in HVAC energy use, humidity levels in the UK are predicted to decrease in line with the increase in temperatures that we're experiencing. And so evaporative cooling technologies could become more and more suitable going forwards. The use of natural ventilation is also recommended in WHO's Back to Work guidelines as a method to increase fresh air rates in spaces without obviously putting any extra load on the AHUs. Studies have shown that the use of natural ventilation, or even using a mixed mode air conditioning system, can result in energy savings of between 47 and 79%, giving an average saving of £30,000 for a typical building. Now, this increased fresh air supply can also improve occupant comfort and productivity, as we talked about earlier, but is it necessarily a safe option? In the UK, we're meeting almost all of our own air pollution targets, aside from nitrogen dioxide, where 77% of monitored zones in 2019 exceeded our target of 40 micrograms per metre cubed. Now, the WHO just released in September new global air quality guidelines, and they limit annual nitrogen dioxide exposure to 10 micrograms per metre cubed, which is 75% less than our target. And we're not even meeting our target in 77% of the country. Our acceptable limits for PM10 and PM2.5 are also 62 and 75% higher, respectively, than the new WHO limits. A study in 2017 showed that indoor air quality in London buildings is often as bad and sometimes even worse than the air outside, even when the space is mechanically ventilated. So I'm going to show you guys some graphs here. So you can see this is the mechanically ventilated building is in a building in central London, and the naturally ventilated building is in North London. But we can see here that the levels of nitrogen dioxide inside the mechanically ventilated building were well below that outside, though both levels inside and outside were recorded to be much higher than the short-term exposure limit set by the WHO. And on the other hand, the natural ventilated building, the level of nitrogen dioxide was higher outside, inside and outside than the level, and both levels were above the exposure limit. So we can also see, again, this is for showing levels of PM10 and PM2.5 in the same naturally ventilated and mechanically ventilated buildings. So we can see that whilst outdoor levels of PM10 were recorded to be lower than the WHO limits in both locations, levels were worse than inside than outside in most rooms, with the mechanically ventilated buildings and worse for all the rooms in the naturally ventilated buildings. And if you look at the graph on the right for room 3, we can see that in the naturally ventilated building, the levels were in fact higher than the WHO limit, and the level of PM10 inside the building was 75% higher than the level outside the building. Levels of PM2.5 are also shown to be higher than the WHO limits outside both of the locations and also inside the majority of the rooms. And again, the levels of PM2.5 inside the naturally ventilated buildings were all worse than outside. So the big takeaway from these stats is that when a building is naturally ventilated, the air quality is likely to be a lot worse than the air outside, whereas at least with mechanical ventilation, it offers a bit more control over the air quality. However, in the space monitored, it's clear to see that the filtration system in the building was unable to effectively capture the smaller particulate matter. And this is an issue as PM2.5 is considered to be more harmful than PM10 as it can reach deeper parts of the lungs. So we want to obtain this safe air. I think maybe in mechanically ventilated buildings, at least, we're going to need better filtration. So typically, air handling units use filters of the class EPM1 to 10, which basically means that they're efficient at removing particles from 0.3 to 10 microns in size. Although these filters can remove particulates from sources such as vehicle exhaust and smoke, they're not necessarily capable of capturing those smaller pollutants. So filters more capable of these requirements are high efficiency particulate air filters or ultra-low particulate air filters, which can capture almost all particles down to 0.3 microns and 0.12 microns, respectively. These filters are typically used, especially the ULPA filters, they're typically used in specialized situations, so clean rooms and then also hospitals. And maybe the reason they're not used more widely is because you do get a lot higher pressure drop using these filters than you do regular filters. And you also have to maintain and clean the filters a lot more regularly. So all in all, they're definitely a less sustainable option than their regular filter counterparts, though they can definitely increase the indoor air quality. There are, however, other technologies available to clean air streams, such as bipolar ionization, and then there are even some that supposedly can help reduce HVAC energy use, namely UVC or ultraviolet germicidal irradiation, which has already been used to sterilize drinking water for about 100 years. Now, UVGI systems work by inactivating and destroying airborne pathogens and microorganisms. And in terms of disinfecting air, UVC can be used as a standalone unit within a space, and where a fan is used to draw air in and force it past UV lamps to kill the pathogens, or the UVC lamps can be placed actually in the air handling unit itself. And it's in this way that UVC can actually help improve the energy efficiency of an HVAC system. So by positioning the UV lamps next to a cooling coil, the UVC can deal with the pollutants to give the cleaner air, whilst also eliminating the buildup of organic matter on surfaces within the AHU. And then this helps to maintain the as-built efficiency. So pressure drops and heat transfer levels remain relatively unchanged. And this can result, according to studies, in energy savings between 4 and 25%. So as with everything, there's a downside to the use of these lamps. The lamps must be well maintained, with a typical UVC lamp lasting about a year. And installation and replacing the lamps can obviously be expensive, although you'd hope some cost savings would be likely due to the lower energy demands and potentially from better employee health from the improved air quality. So since the beginning of the pandemic in March 2020, our view of what is important in a space has been altered. Indoor air quality wasn't talked about nearly as much as outdoor air quality, although it's now widely accepted that ventilation, or the lack of it, can cause an outbreak of a potentially deadly virus. I found that this increased concern for occupant health is reflected in the emergence of indoor air quality certification for buildings, where humidity and temperature and levels of pollutants are monitored to give an analysis of building health. We're also still tackling COVID-19. As we've seen in the news recently, infections are still climbing despite vaccinations. And so it probably means that building management are still required to implement mitigating strategies, like increasing the fresh air percentages where possible. Modelling from an American company that tracks infectious disease risk and outbreaks suggests that we're 25% likely to experience another epidemic or pandemic in the next 10 years. And those 10 years is not a very long time away. Plant equipment installed now is probably still going to be running in 10 years' time. So maybe if what we're installing at the moment can be capable of combating viruses now, then we'll be much more ready to manage the risks associated with ventilation in the future if need be. Our concerns surrounding indoor air quality and pandemic resilience are all well and good, but we must ensure that they don't come with an increased energy demand. The built environment is responsible for the production of 10 gigatons of carbon dioxide globally each year. And so as a nation, we might have our own decarbonisation targets, but the positive impact is only going to be made if there's a global effort. But maybe for now, what we can do is show that we can design buildings with excellent indoor air quality whilst effectively working towards net carbon zero, even in a polluted city like London. Then maybe other cities and countries will be able to follow suit. Thank you.
Thanks, Ella. That was really, really interesting. I've got a couple of questions for you. Firstly, what do you think is the biggest impact on our health from a ventilation perspective?
So I think the indoor air quality it's definitely becoming more understood, like the importance of it. I read an article just in CIBSE, this month's CIBSE magazine just this morning, talking about another study that's found the mental impact of low air quality. And I think it's kind of that thing, you can't see it, so it's harder to understand how important it is. So I think probably that, and you don't realise necessarily, like I live in London, I have my whole life, probably the air quality that I've been breathing is having all this negative impact that I don't even know about, and we're subjecting our occupants to it unbeknownst to them, you know. So I think that's probably the biggest, in terms of occupant health, that's probably the biggest problem we have to overcome, really.
It's a silent thing, isn't it? It's not something you can really
Silent killer,
see.
exactly.
Yeah.
Like
And I guess
said,
that's the same with. Well,
no, I was just going to say with temperature, like I said, it's when it's cold, you know it's cold. You can feel it. It's immediate. It's something you can complain about. But again, with the sick building syndrome, it took people 5-10 years to realize, oh, the reason that people are coming to work and sitting in these offices and getting sick, it's because of the ventilation. It just took them that long to realize it. And obviously, there was the case with a girl in London, the first case with in air quality was put on her death certificate. It's taken time for us to realize how negative and how huge the impact actually is. So
yeah, no, and as you say, mental health, it impacts on mental health without, again, which is another silent thing, isn't it? You don't see so much. Out of all those technologies that you've talked about, which do you think can give us the best sort of bang for buck in terms of balance against health versus sustainability?
well, to be honest, if companies need to make the investment to make the change, right? But to be honest, a combination of a bunch of them, really. So you can use displacement ventilation in some situations, and then that is effective at improving the indoor air quality and also lowering so you're literally not loading anything else on the HVAC system. You're only decreasing that, whilst also the benefit of the indoor air quality is there too. So that's a really obvious one, but like I said, it's not always the most appropriate. Then evaporative cooling. It does require, so maybe not obviously retrofitting. You might as well just stick with what you've got in terms of that. But if you're specifying a new air handling unit, why not look at using evaporative cooling? Because water. It's the same water in there. It's recycled, so it's not the amount of water required is not huge as well. That's a benefit. And then if you put those UVC lamps in as well, then you are also going to be helping increase your air quality and reduce the build up and improve the efficiency as well. So I think probably a combination of all of them. If you can possibly make the investment. It's easier said than done, but I think things have got to change in terms of what people are willing to pay for. So we'll see.
It's quite difficult, I guess, to do that return on investment statement, isn't it? How do you value that if it's a help?
But then on the flip side of that, there are some things that you won't necessarily be able to quantify, like reducing, or if you do improve the indoor air quality, you could well increase your productivity, occupant health as well. It means you're having less sick days, and you're making more money as a company because you're not losing money to those sick days as well. So there are some things that you can't just go, it's not black and white in that sense. It's kind of a trust that it's going to work out.
Yeah, and I guess we haven't got enough baseline studies yet on this to be able to use that, have we?
Not necessarily. Probably not.
No, so probably need to start some of those, I guess. To kind of make sure, yeah. You mentioned that scary thought that actually within the next 10 years there's quite a high percentage chance of us having something else, that something else that might come up behind us from COVID, and something else that we might have to deal with. That's quite a scary thought, isn't it? If we're not ready for it.
Yeah, it's obviously it's all modelling and that kind of thing. It's not 100%, but it was, if you think SARS was only 18 years ago, 19 years ago. And although I don't think it impacted the UK in the same way that the COVID has, it's still the same thing. And to be honest, if you make the building resilient to viruses now, even things like winter flu, it could help mitigate the common cold. Obviously, we've all experienced being in the office in the winter or something. If somebody gets a cold, it definitely spreads quite easily. So even mitigating things like that, I think if we can implement it, then we'll just kind of helping ourselves out potentially for the future. Obviously, touch wood, it never happens again. in our lifetimes or ever, but whatever, sometimes it does. And yeah, I think if we can be prepared, why wouldn't we be?
Cultural change needed, huh?
Definitely. Yeah, definitely.
Yeah. Thank you very, very much. It's been really interesting. Hopefully we'll all start thinking about getting prepared for this, because I think, as I said, accountability and cultural change is required, isn't it, to help
Yeah, for sure.
adopt all those technologies. Thank you, Ella.
Thank you very much, Helen. Thanks, everyone.